What does it take to make an electronic product reliable? Is it better design, better materials, better testing, cleaner assemblies, tighter process control? The truth is, reliability is never the result of just one thing. It's the result of thousands of decisions made by many people across the entire life of a product. For nearly 200 episodes, I've had the privilege of exploring those decisions with some of the most knowledgeable people in the electronics industry. We've talked about failures, discoveries, changing technologies, hard-earned lessons, and the practices that help turn good products into dependable ones. Today, there's no guest. Instead, we're going to look back at conversations, the people, and the ideas that brought us to a very special milestone. Welcome to episode 200 of Reliability Matters. I'm your host, Mike Konrad, and today's episode is going to be a little different. As I mentioned earlier, there's no guest joining me today. Instead, I'm taking a moment to pause, look back, and celebrate an important milestone, the 200th episode of the Reliability Matters podcast. 200 episodes! When I recorded the first episode, I wasn't thinking very far ahead. I certainly wasn't imagining what episode 200 would sound like. I simply wanted to create a place where people throughout the electronics industry could have honest, technically meaningful, and commercially unbiased conversations about reality. The idea behind the podcast was simple. Reliability is never the result of one decision. It isn't created by a single material, machine, test method, standard, or department. Reliability is the accumulated results of thousands of choices made through the life of a product. It begins with design. It continues through material selection, component sourcing, fabrication, assembly, cleaning, inspection, testing, environmental protection, packaging, transportation, installation, and field use. It also depends on people. It depends on training, communication, leadership, experience, curiosity, and the willingness to change assumptions when something doesn't seem right. Every one of those decisions matters. That's why reliability matters. As I prepared for this episode, I looked back at the conversations we've had since episode 100. The range of subjects has been remarkable. We've discussed design for manufacturing, component selection, fabrication processes, laminate availability, advanced packaging, semiconductor supply chains, and the continuing effort to strengthen electronics manufacturing right here in North America. We've examined what happens once a product enters assembly. Our guests have discussed soldering, reflow profiling, hand soldering, rework, robotic soldering, component placement, tape splicing, inspection, testing, automation, production software, data collection, and the practical realities of implementing Industry 4.0. We've also talked about the fundamentals that manufacturers sometimes overlook: process control, workmanship, training, documentation, troubleshooting, maintenance, and the importance of understanding what is actually happening on the production floor rather than relying entirely on what we assume is happening. We've discussed contamination and cleanliness and its effects on reliability. We've also spent a great deal of time discussing electronics designed for harsh environments and demanding environments. Our guests have explored conformal coatings, nano coatings, encapsulants, moisture protection, environmental testing, and the challenges of protecting assemblies from humidity, corrosion, vibration, temperature extremes, and chemical exposure. We've discussed the differences among coating materials, the importance of surface preparation, and the reality that even the best protective material can fail when it's applied to a contaminated surface or used in the wrong environment. These discussions have taken us into automotive electronics, aerospace, defense, medical products, industrial controls, and other applications where failure can have serious consequences. Another reoccurring theme has been the role of inspection and testing. We've discussed automated optical inspection, X-ray inspection, artificial intelligence, counterfeit component detection, electrical testing, environmental testing, accelerated life testing, and failure analysis. We've asked difficult questions. Does a passing test mean a product is reliable? Are we testing the right things? Are we creating test conditions that represent the actual operating environment? Are we collecting data because it helps us make better decisions or simply because modern equipment allows us to collect it? Our guests have reminded us that inspection and testing are valuable tools, but they can't compensate for poor design or an unstable manufacturing process. You can't inspect reliability into a product after the important decisions have already been made. Over the past several years, artificial intelligence has become an increasingly important topic on the podcast. We've explored AI in inspection, manufacturing analytics, training, troubleshooting, design, and decision-making. We've discussed how artificial intelligence may help manufacturers recognize patterns, analyze large amounts of production data, identify defects, improve efficiency, and preserve valuable technical knowledge. At the same time, we've tried to approach the subject realistically. Artificial intelligence is a tool. It isn't a substitute for engineering judgment, process knowledge, or experience. A faster answer isn't necessarily a better answer, especially when the data behind it is incomplete or misunderstood. We've also explored technologies beyond traditional electronics manufacturing, including quantum computing, liquid metals, flexible electronics, wearable ESD monitoring, advanced materials, and other developments that may shape the future of our industry. Reliability extends well beyond the production line. We've discussed component shortages, counterfeit parts, trusted suppliers, material availability, sourcing decisions, domestic and overseas manufacturing, and the risks hidden throughout the global electronics supply chain. We've also examined cybersecurity, ransomware, network reliability, data protection, and the increasing dependence on manufacturing operations on connected systems. A product may be well designed and carefully manufactured, but still fail to reach the customer if the supply chain breaks down, critical information is compromised, or the factory itself is unable to operate. These subjects may not always be viewed as traditional reliability topics, but they absolutely affect whether a company can consistently deliver dependable products. Another important part of the podcast has been our focus on standards and education. We've talked with people involved in creating and maintaining industry standards. We've discussed how standards are developed, why they change, and why engineers and manufacturers should participate in that process. We've also explored different ways of teaching technical subjects. Training can't simply consist of presenting information and assuming it's being understood. Effective education requires context, examples, repetition, engagement, and opportunities to apply what has been learned. This leads to one of the biggest challenges facing the electronics industry today, the loss of institutional knowledge, the brain drain. Many of the people who helped build the modern electronics manufacturing industry are retiring or at least preparing to retire. When they leave, they take decades of practical experience with them. That experience often includes knowledge that was never written down. It includes the ability to recognize subtle process changes, interpret unusual defects, understand material behavior, and remember solutions to problems that may not have appeared for many years. Several of our guests have emphasized the importance of mentoring, documenting, teaching, and preserving this knowledge for the next generation. That mission is also an important part of Reliability Matters. Reliability isn't only technical. We've had conversations about hiring, leadership, mentoring, career sustainability, burnout, communication, and organizational culture. A company can purchase the best equipment, select the best materials, and implement sophisticated quality systems, but those investments won't produce reliable products if employees are afraid to report problems or if management rewards output while ignoring process discipline. Culture affects reliability. Leadership affects reliability. Communication affects reliability. The strongest reliability programs are usually found in organizations where people are encouraged to ask questions, challenge assumptions, share knowledge, and stop a process when something just doesn't look right. We've also examined the environmental impact of electronics manufacturing. Our guests have discussed more sustainable fabrication methods, environmentally responsible coatings, waste reduction, water conservation, chemical management, energy consumption, and the challenge of balancing environmental goals with performance and reliability requirements. Sustainability and reliability are closely connected. A product that fails prematurely must be repaired, replaced, transported, and sometimes discarded. Improving reliability is therefore one of the most effective ways to reduce the environmental impact of electronics. A reliable product lasts longer. A reliable process creates less scrap. A reliable manufacturing operation uses resources more efficiently. None of these conversations would have been possible without the guests who generously shared their time and knowledge. To every engineer, scientist, educator, consultant, designer, manufacturer, standards expert, and industry leader who has joined me on this podcast, thank you. Thank you for preparing for the conversation. Thank you for explaining complicated projects in ways others could understand. Thank you for sharing your successes. And perhaps most importantly, thank you for being willing to discuss the problems, failures, mistakes, and lessons that are often the most valuable parts of an engineering career. Some guests join me from offices, laboratories, classrooms, factories, conference centers, and trade show floors. Others join from home, sometimes separated by thousands of miles and several time zones. Regardless of where the conversation took place, each guest contributed something valuable to the growing library of information represented by these 200 episodes. I also want to thank you, the listeners and viewers. Some of you have been with the podcast since the earliest episodes. Others discovered the program through a particular guest or a technical subject and stayed for the conversations that followed. You've listened while commuting, traveling, working in laboratories, sitting in offices, or walking through manufacturing facilities. You've shared episodes with coworkers, students, customers, suppliers, and colleagues. You've sent questions, suggested guests, recommended topics, and offered encouragement. Podcasting can sometimes feel like speaking into an empty room. Your messages, comments, downloads, and conversations have been a constant reminder that someone is listening, someone is watching, and that these discussions are useful. Thank you for allowing Reliability Matters to be part of your professional life. I also want to recognize the organizations that help bring this podcast to an even wider audience. Thank you to the Printed Circuit Engineering Association, PCEA, which syndicates Reliability Matters at PCBchat.com. The PCEA has long supported education, communication, and professional development throughout the printed circuit engineering community. I'm grateful that Reliability Matters is included among the technical conversations they share with the industry. I'd also like to thank Ascendo Reliability, which syndicates this program through reliability.fm. Ascendo Reliability has built an extensive educational resource for reliability professionals, and I'm honored that this podcast is part of that platform. These partnerships help the conversations reach engineers and reliability professionals who may not otherwise have discovered the program. I'm extremely grateful for that support. From the beginning, I made the decision not to accept advertising or sponsorship for Reliability Matters. That decision was intentional. I wanted guests to speak openly and honestly without feeling an obligation to promote a particular product, company, or technology. The podcast is inspired by education, not advertising. That independence allows us to discuss advantages and disadvantages, successes and failures, and competing technical approaches without commercial pressure influencing the conversation. There's certainly nothing wrong with sponsored technical content when it's identified as such, but Reliability Matters was created to serve a different purpose. The goal is to provide conversations that are useful, credible, and focused on helping people build more reliable products. Reaching episode 200 is certainly worth celebrating, but this episode isn't intended to be a finish line. There are still countless subjects to explore. Electronic assemblies continue to become smaller, denser, more powerful, and more complex. Products are being placed into environments that demand longer life, greater performance, and higher reliability. New materials, components, manufacturing methods, inspection systems, and artificial intelligence tools are being introduced at an extraordinary pace. At the same time, many of the fundamental challenges remain unchanged. Understanding the process, controlling variation, selecting the right materials, keeping assemblies clean, protecting products from the environment, training people effectively, preserving knowledge, and remaining curious when the results don't match our expectations. The mission of Reliability Matters will continue to be bringing knowledgeable people together to examine these subjects openly, practically, and without unnecessary commercial influence. The goal isn't to provide every answer. The goal is to ask better questions, share useful experience, and help all of us think more carefully about the decisions that influence reliability. 200 episodes represents hundreds of hours of conversations, preparation, research, recording, editing, and production. But more importantly, they represent hundreds of hours of shared knowledge. Knowledge about materials, knowledge about processes, knowledge about failure, knowledge about people, and knowledge about what it takes to create products that customers can depend on. To every guest who has appeared on the program, thank you. To the Printed Circuit Engineering Association and PCB Chat, thank you. To Ascendo Reliability and Reliability.fm, thank you. And most importantly, to every person who has listened, watched, subscribed, commented, shared an episode, or recommended Reliability Matters to a colleague, thank you. I truly appreciate your support. I'm proud of the first 200 episodes, and I'm excited about the conversations still ahead. Until next time, remember that reliability isn't accidental. It's created by the decisions we make, the questions we ask, the processes we control, and the lessons we're willing to learn. Because in electronics manufacturing, reliability really does matter. I'm Mike Konrad. Thank you for joining me for episode 200 of Reliability Matters. I truly appreciate each and every one of you, and I'll see you again in 2 weeks for episode 201.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.